Question number 8. Here function is from A cross B to B cross A. You know A cross B is set of ordered pairs. So here one member is A comma B. The corresponding member is just reverse like this. For example, if I have f of 1 comma 2, then the image will be 2 comma 1 like this. If I take here 3 comma 4, then the image will be 4 comma 3. This is what it says. We show that it is bijective. This is the question. We show that here f is bijective. Bijective means it is 1 1 and on 2. F is bijective. It's not so difficult. Let's see this. So I'll start with this. Suppose f of, now I need to take two members, that is ordered pairs. One I'll take A comma B equals to f of C comma D. And at the end I need to show that here A comma B equals to C comma D. This is what I need to show. This is like x1. So whenever f of x1 equals to f of x2, then x1 equals to x2. Now what's the meaning of f of A comma B? You know by definition B comma A. What's the meaning of C comma D? You know D comma C. So if you have this, then obviously you have this. So therefore what you have shown, f of A comma B equals to f of C comma D. It implies A comma B equals to C comma D. This is like x1 and x2. So therefore f is on 2. F is 1 1 function. F is 1 1. Now, so this is 1 1 function. For on2 part, second one, for on2ness, I'll give that general proof. So let's take one member y equals to, for example, A comma B from the codomain, that is B cross A. I've taken one ordered pair from codomain. We find, as you know, now I did twice, we find a x. So again one ordered pair from the domain. You know how to do this, but still I'll explain, such that when I find fx, I must get y. Now how to find this? That is, you just go back to this example. If you are given this, your y you are given, and you want to find the corresponding member. So how you are finding this? Just the reverse of this. If you have 4 comma 3, you are using 3 comma 4. So here I should write B comma A. This is just from concept of the function. Now if I write f of x, which is B comma A. Now what is the definition of function? You go back to this, reverse the ordered pair. So you'll get the A comma B. What was A comma B? It is y. So therefore you can say that for every y in the codomain, there is x in the domain such that fx equals to y. So therefore f is on 2. Therefore f is on 2. So here f is 1 1, f is on 2, and therefore it is bijective. So therefore f is bijective. F is bijective function. Bijective means both 1 1 and on 2. Next, this is very important example, is again standard function, linear upon linear. Usually such functions is always 1 1 and on 2. This both normally. Here domain is all real numbers other than 3. Why 3 is eliminated? Because you have upon x minus 3. You cannot write f of 3. So it becomes undefined. Why 1 is eliminated? You will realize later on. But normally such functions, linear upon linear, are usually in 99% of the cases would be always 1 1 and on 2. That is bijective. Let's see here. So the first part, that is 1 1 part here, 1 1 part, 1 1 or not we want to see. So we start with this. Suppose I will take f of x equals to f of y, right? And at the end you are going to show here, you will see, you will show x equals to y. Now write, this is for every x y from the domain, remember, from the domain that is R minus singleton 3. Write the meaning of f of x minus 2 upon x minus 3. F of y is y minus 2 upon y minus 3. Do the cross multiplication, x minus 2 into y minus 3. Here y minus 2 into x minus 3. Just open the bracket. So if I open the bracket, this is xy, this is minus 3x minus 2y plus 6. This is xy minus 2x minus 3y plus 6. So this 2 will get cancelled. About this 2 you will get x here. About this 2 you will get y. So you can just see that this is x equals to y. So therefore you have shown that fx equals to fy. It implies x equals to y for every xy in the domain. So therefore f is here 1 1 function. F is 1 1 function, remember. In this case the function is 1 1, linear upon linear. Now on to part. So I'll go to on to part here. So on to part. So we know method. Take y from codomain. Find x. This from domain such that fx equals to y. This is what we want to do here. So I'll take one. Let's take y from codomain. Y belongs to codomain. Okay. We find x. We find x. Now how to find x? You know method. So you can just show here inside the bracket or here. What's the procedure to find this x? This is a method. Take fx equals to y as I explained earlier. This is very important part in subjective, remember, in subjective questions. We are trying to find x. We are given y here. So this is a method. Take fx equals to y. Write the formula for function, which is x minus 2 upon x minus 3 equals to y. Now you get x as a subject of expression from this. So x minus 2 equals to, if I take on the other side, xy minus 3y. I want x, remember. So I'll take this one on this side. So x minus xy equals to 2 minus 3y. Take x common, so we'll get the 1 minus y equals to 2 minus 3y. So what is x from this? 2 minus 3y upon 1 minus 1. What you did, important part is make x as the subject of expression. That's what I did basically. This is simple algebra. So this is my x. What is my x? 2 minus 3y upon 1 minus y. From where this will come? This will come from the domain, remember. That is R minus 3. Now remember, this is defined. Why this is defined? Because you cannot take here y equals to 1. See, y comes from the domain. That's why this is defined. This never be 0 because y never be 1. So we find x. Usually you show this much in the exam also by just drawing a line here like this. You show this such that now if I find f of x, at the end I'll get y. So let's see this. So f of x, that is f of, what is x? That is this much, 2 minus 3y upon 1 minus y. Now use the formula for function. What's the formula for function? You know formula for function, x minus 2 upon x minus 3. This number minus 2, this number minus 3. So this number minus 2, 2 minus 3y upon 1 minus y minus 2. This is the formula for function, upon 2 minus 3y upon 1 minus y minus 3. You simplify this, you will get exactly y. So you have shown that for every y in the codomain, there is x from the domain, all real numbers other than 3, such that fx equals to y, and therefore f is onto. And therefore you can say that f is bijective function. This is 1 1 and on to both. This is bijective. I repeat this portion here. For every y in the codomain, now this is 4th time we are doing the same thing. You need to find x. So how do we get this? I've explained here. Take function equals to y, write the formula for function and get x from there. Just make x as a subject of the expression. So x is this. Here x is this much. Placed here. Now apply the function f of x. But what is x? That is this much. Now what is the rule for the function? This number, you look at this. What is fx? This number minus 2, this number minus 3. If I write 100 here, 100 minus 2, 100 minus 3. So you imagine this bracket as 100 here. So 100 minus 2, 100 minus 3. And you just simplify this much. I leave it to you. If you simplify this, you will get exactly y. So therefore you have this, and therefore it is bijective. Question number 11 here. Function from R to R, fx equals to x raised to 4. All real numbers. So very easily you can notice, if I write 1 raised to 4, 1. Even if I write minus 1 raised to 4, which is also 1. So what is your obvious conclusion? Not 1, 1. Right. This is obvious conclusion. What about onto part? You know, raised to 4 being even power, this is always greater than or equal to 0. So fx is always greater than or equal to 0. So what is RF here? All positive real numbers with 0. So 0 to infinity. Is it same as codomain? No. Codomain is R, not equals to codomain. So what's the conclusion? Not onto also. So this is not 1 1, not 1 1, not onto. So correct option is D here. Neither 1 1 nor onto. 12th question. F from real numbers to real numbers. Fx equals to 3x. Now recall just that remark. This is a function from R to R. What is this? This is a function of this type. Fx equals to ax plus b. Here b is 0. So this is a linear function. Linear function from where to where? R to R. So it is always bijective. So f is here bijective. Every linear function every linear function from R to R is always bijective. So bijective means 1 1 and on to. So correct option is A.